in so many means. Thank you. So, so today we would meet Mr. Jans Assmann, and we were going to learn about visualization tools, which are important for so many reasons and so many KM needs. But when we come to big data projects and AI and and machine learning projects, they even get more, they get, the importance even exceeds. So today, under the umbrella of AI projects and under the umbrella of AI serving KM, we will know to learn this world of AI visualization tools. And Annie, you will be the host. So please start.
Hi, good day to everyone. I'm going to just give you a little bit of background on Dr. Jans Assmann. He is a psychologist and an expert in cognitive science, and he's the CEO of France Incorporated. He is an early adopter innovator on artificial intelligence and a provider of knowledge graph solutions based on Allegro Graph. As both a scientist and CEO, Dr. Assmann continues to break ground in the areas of artificial intelligence and knowledge graphs as he works hand in hand with numerous Fortune 500 organizations, as well as government entities worldwide. So we're going to see where with knowledge visualization, Dr. Assmann or Jans is actually going to take us through an understanding of the Allegro Graph tool, as well as to give us a demonstration. So with that, I'm going to actually turn it over to Hans Assmann. Hans, I'm going to be monitoring the chat and making certain of questions. So I'll be in the background making certain that I support you, okay?
All right. So then I'm going to share my screen. Let's see here. So you guys can see my screen now?
Yes, everyone sees it.
Okay, perfect. Yeah. So so I'm going to talk just about, I've been working, as Annie said, I've been working with knowledge actually kind of all my working life. As a psychologist, I was already doing modeling human behavior in semantic networks. So yes, I've always been in there, and I always felt the need that I have to see what I'm actually doing. There's so many people that work in the area of graphs and knowledge and kind of do it all in their head. It's very hard to communicate what's actually in your knowledge graph, right? So that's why we've been working really hard on a tool to make it easy to visualize graphs. And let me talk a little bit about my company before I continue. Let's see here. Okay, so we're in California. Our main product is called Allegro Graph. It's a semantic graph database. But if you look at the main work that we do right now, is we help companies build their own knowledge graphs. And we have a special brand of knowledge graphs that we call entity event knowledge graphs. And I'll talk a little bit more about it today. Well, when we started out building our product Allegro Graph and Graph, that was like 14 years ago. We only had defense customers, right? Because people in defense are figuring out, how can I take entities like human beings, organizations, and events that happen and tie them all together, right? So they were trying to figure out, how do I do that all together? And all the graph database companies like ours were also trying to figure out, how do you make that scalable and workable? And so actually the US Army was our first ever customer, where they tried to match the educational needs of about 2 million soldiers with a catalog of courses that had 100,000 courses. And how do you match the need of a soldier with all this rich amount of courses? And so that thing is still in production. Anyway, there's many stories to tell. Let's not do that today. And then about 10 years ago, the commercial world woke up. So initially it was all the life science companies. I don't know if there's life science people in the audience. But of course, life science people have to deal with the most complex objects in the world, namely ourselves, our physiological processes, chemical processes, so many things that they needed taxonomies and ontologies. And so they kind of came to us because they needed the kind of technology that we were using. But recently, it kind of completely opened up. Banks are deep into graphs and knowledge graphs, hospitals, call centers, and again, lots of stories to tell, but not today. So why knowledge graphs? I'm guessing you guys are in knowledge management, so there must have been a speaker before me that already talked somewhat about knowledge graphs. Yeah, and maybe you've even seen this picture already, that there's this crazy interest in representing all kinds of information, including knowledge, using graphs. Yeah, so I never thought it would go on this long, but the interest in knowledge graph is still still growing fast. And if you look at Gartner, who's always following the market, right? And you see in this is the traditional hype cycle that in 2018, for the first time, knowledge graphs appeared on their radar. 2019, it was already halfway the top. In 2020, knowledge graphs are at the top of the hype cycle. So that was kind of a very interesting phenomena to see. And we see it too, because our company is doing well, because we're building knowledge graphs for all kinds of companies. But what is a knowledge graph? And again, you might have had it already, but my definition is a system that knows and learns everything it can about an entity of interest. Yeah, to improve internal processes, customer experience, health. So I always define a knowledge graph as a learning system. And in the cases that we build them, they always include a semantic graph. It always starts with the taxonomy. What are the important words in your domain? Yeah, what are the important concepts in your domain? And how do you take information from all your silos and use the ontologies and taxonomies to tie it all together? And in every knowledge graph that we're building right now, there's a component of machine learning, natural language processing, text classification. And recently, and this is one of the new specialties of our company, speech recognition. Yeah, it's a new frontier where you can listen to what your call center people are saying to your customers. We can listen to that, analyze it with NLP, and then learn about the voice of the customer. So very interesting. And we, of course, take the output of all of that and put it in our knowledge graphs. So this is roughly kind of how I think about knowledge graphs. And then literally everyone is building knowledge graphs right now. Big tech is doing it, and we're helping smaller customers. Yeah, so Google actually coined the term knowledge graph. And basically it was a system to make their search better. So if you search for something and you see this thing here on the right, then you know it actually came from their internal knowledge graph based on Wikipedia. And right now they have about 70 billion facts in their knowledge graph, and it's growing fast. Apple uses knowledge graphs. I've seen several talks about it, how to make their Siri better. LinkedIn has one of the most beautiful knowledge graphs in the world, right? Everyone is envious of that because they literally have every company in the world, every skill that you can think of, every employee, their history, and it's an incredibly valuable knowledge graph. Internally, they call it their economic graph. And even Amazon gives lots of talk right now about how they use knowledge graph to tie knowledge about the world to the knowledge and the inventory that they have of all the things that they're selling. So, and then again, as I said, top 500 is into this. So, for example, I was just recently at a conference, and you see that in one session, Goldman Sachs and Capital One and Wells Fargo are all talking about the knowledge graph that they're actually building. So that is what the big companies do. Then we help companies, and again, I'll almost done with this, and we'll go into the real fun. But our big customers are in call centers, where we actually analyze the interaction between customers and agents. And we try to learn everything we can from what was being said. And then another very, very interesting knowledge graph that I spent an enormous amount of time as a company, and that is where we take data of about 2 million patients, and we turn it into a patient knowledge graph. And we do it in such a way that the complexity of the silo is reduced with the factor 2 orders of magnitude. So now for us, it's very easy to do queries, feature extraction for machine learning, create 360 views, etc. And I'll talk a little bit about that. Then in the Netherlands, the tax authority there is using a knowledge graph to find influence networks in their country. So they have, and I'll talk about it. That's my first demo, where we see all the legal entities in a country and all the relationships between them and what you can do with that. And I could go on. So actually, I'll just well, and this is a fun one. This is a company, Essilor. Most people haven't heard of it, but they provide global eyewear in 200 countries, multi-billion-dollar industry, and their entire inventory is stored in a Lego graph, in a knowledge graph. And every time you buy anything from that store, it actually will go to our knowledge graph to ask about pricing and all kinds of information. Peak load 7,000 times per minute, we get a query in that particular knowledge graph. Anyway, enough bragging. Let's now go to the fun part. And by the way, I'm talking here to a screen, right? Which is not my really hobby, just talking to a screen. I really hope that if you guys have questions, just ask questions. Yeah, I don't mind being interrupted. I actually like to be interrupted. So I'm going to give you a bunch of demos. If you have questions, just ask, right? Just ask. Okay, so I talked a little bit about the background of what we do, but today is about visualizing knowledge, where knowledge, I mean, I'm a psychologist, so I could now go on a 10-minute talk about all the ways you could define knowledge, but let's skip that. Let's just say, let's take an intuitive knowledge about what knowledge is, right? And how it's represented in a graph-based representation. And then I'm going to show you how we use a tool called Gruff to analyze that. Now, if you want to try this out, you can go to our website, allegograph.com/product/gruff, and you can just download it together with Allegro Graph. It's free up to like 5 million triples. We have some demo data sets that you can use, so you can just try it out for yourself. And on this web page is also a link to a cloud-based version where you can start playing if you wanted to. And so what are the things I'm going to demo today? What are the visualization aspects of the tool that I would like you to get familiar with? Well, I'll use 3 use cases to show that, but I'll start with the legal entity knowledge graph for the Dutch tax authority, and I'll show you how you can kind of navigate a graph. So how do I go through the nodes and the edges in the graph? How can I just take any 2 edge nodes in the graph and find the relationships between them in various ways? And then everything in life is temporal, right? I mean, you can have static knowledge graphs, but I call them usually boring because nothing moves. But the interesting ones are things that try to capture real life. If you capture real life, there's a temporal aspect to it. So we also visualize temporality in graphs, and I'm going to show that. And then when you want to write queries in graphs, it's not easy. You know, you have to kind of write a lot of stuff. So we created a no-code way of creating very complex graph queries, and I'm going to demo that too. So that is the first 4 things I want to show you. And then I'm going to talk about how you can take, I'm using the patient knowledge graph that we built for a hospital, how you can take complex silos that you have in a hospital and kind of radically simplify that into entity events. And I'll show you how they look like. And then I can show you how you can link patient events to taxonomies and ontologies. Yeah, so the data from silos are real world events, but if you put that in a database and you don't link it up to the taxonomies that describe the words that are important to you, then you don't have anything. So every knowledge graph needs to have a central taxonomy that describes the most important words in your application. And then one of the things we specialize in is we do a lot of machine learning and analytics on our graphs, and we always take the output of that analytics and put it back in the graph. So part of the knowledge we have in our graphs is also just statistical knowledge, how things are related. And then finally, if we still have time enough, I'll talk about the document knowledge graph for Noam Chomsky. So we work for companies and we take documents and analyze them with NLP and then turn them into beautiful document knowledge graph. that I don't have a single customer that allows us to show their data to an audience. So we took a little example, the work of Noam Chomsky, and we created taxonomies for that, do NLP on his work, and then showed it in a beautiful knowledge graph. Okay, so this is kind of what we're going to do. And now let's begin with the first use case and the first demo. So in the Netherlands and every other country in the world, it's of course a favorite hobby of many companies to cheat the tax, right? And if you do fraud, yeah, then the fraud has almost always to do with relationships between companies. Yeah. So for example, people play shell games, or they try to do revenue boosting where A sells to B, B sells to C, and C sells to A again. So it looks like your revenues are bigger. And so if you so what we have in the Netherlands is they took all the data from the Chamber of Commerce that has all the relationship between companies, all the important people that work for these companies, yeah, put it into a knowledge graph, and then we have the temporal relationships between any two legal entities, yeah, because you're a CEO from a start time to an end time, you're an owner from a company from a start time to an end time, you are at a particular address from a start time to an end time, etc., etc. Yeah, so all these relationships are temporally bound. Okay, enough words. So now let me stop sharing and let's go to the demo. Okay, so let's see, share my screen here. Okay, Annie, can you see my screen, or Moria?
Yes, we can see your screen.
Okay, so say,
It looks
so you
like
have,
a kite.
yes. So say you have every legal entity in your country, yeah, and the important relationships between them. Well, and say now you want to find if a particular person has an influence network. Yeah, can one person control a whole bunch of companies? Well, so then what we do is we write the query, and I'll show you later how you make these queries. But this is a query, a graph query. Every thing that starts with the question mark is a variable. And this query says, is there a person with the name Dharminder that performs a role with respect to company C1, and C1 performs a role of type full stock owner with respect to company C2, and company C2 performs a role also of full stock owner with respect to company C3. Yeah. Now this is a tiny query in the Dutch tax. They have this 10 levels deep. But so this is the query, and when I run this, it gets turned automatically into the query language Sparkle, which is the query language of the semantic web. Yeah. And you get the output as a table, just like you would get in a relational database. So in the old days, the Dutch tax people could do a SQL query looking at trying to find an influence network. They would write a 6-page query, and then they would get something, and then they would get this. And I can tell you, there's a beautiful graph in here, but it's represented as a table, so it's really hard to see. So in the old days, they would take pen and paper and start writing the graph on a piece of paper. I just click on this button, yeah, and here I see the graph. And let me get rid of this one. And there's many ways to look at this graph, but this graph doesn't look that pretty. So I can make any node in this network the beginning of a tree. And so now I see the influence network of this person. I see there's a person, Dharminder, who was an executive from the 1st of August 2012 to the 1st of October 2013 for this particular foundation. This foundation was the full stock owner for this company. Here, Falmas. Falmas is a full stock owner of this one, right? So this guy is definitely playing shell games. But what you see here, yeah, the kind of the graph. Now I can click on each of these nodes, and I see all the attributes and links for this particular object. So I see the birth date of this person, the address. I see the ingoing and the outgoing links for this person. So this thick gray line above means outgoing links, under means incoming links, right? So this is one way to look at it. Or I can look at a a role object, the executive role object. I click on this one and I see that there was a start time and an end time for this. And the label is that he was an executive. He got 2 types. Anyway, again, if you have questions, please ask. So one way to look at this
Yeah,
is
quick
just
quick
to,
question, please, Jan. You had something there, weak links and strong links. That's interesting. How do you make the distinction between those 2 types of links?
I'll get back to, okay.
If it's coming later, okay.
I'll
That was
come. No,
interesting.
no, but it's good that you ask. Actually, it's very good that you ask. I'll talk about that. So I can also navigate the graph here. Yeah. So again, here you see your strong links and your weak links. But I can also here look at, say, what was the email of this person, and maybe he has some other roles like stock owner here, and I could go on, and right. So I can just I can navigate this thing on multiple ways. By the way, on the left-hand side, you see these boxes here. These are the classes of the objects. So green is control objects. This is foundations. These one are human entities. This is limited ownerships objects, right? And here are the names of the links between them. Yeah, these are the edges that we have here. I hope you kind of get that. And then, so that is one thing that you can do. Now it's very easy to get something on the screen. So in the when I was still in the Netherlands, I moved to California 17 years ago. But when I was in the Netherlands, I had a company there, so I can always do a text search. Jannes Star as. Yeah, and I found myself here. Yeah, and I could click on this, and I could see that I have a bunch of weak links with other people, and I have a bunch of well, I had an address where I lived, I had a social security number, etc., etc. But the reason I'm showing this is that what usually happens at the Dutch tax is that people take, say, they look for 1, 2, or 3, or 4 companies. Let me throw everything away. I selected 3 of them. Yeah. And then they say, okay, show me how are all these things actually related? Yeah. Can you tell me? And so the first thing you have to do is actually then select the predicates that you want to use, the links to go from A to B. So here are some pre-selected combinations of edges that I can use. Well, let me start with has role, performs role. Yeah. And now I can hit a button here. And what you saw, it was automatically finding the links between these objects, right? Does that make sense?
Yes.
But they were not much shorter. So you could say, well, is there a link between this guy here and then I drag it here? Would have been another one. Yes, but only here. So not very exciting to find out that thing there. So let me go back. Yeah. So that's one way to look at this. Or, but this was only via what I call the role relationships, like am I an executive or a stock owner? But what if I wanted to look for relationships like addresses or telephone numbers or emails, right? So I could just for fun take 2 of these guys here and save them here. And I can say so, and now I'm going to your question, Art. I defined role relationships as strong relationships, and I defined weak relationships, something like an email address or a phone number or a regular address. Yeah. So I could actually say, okay, only use weak links, yeah, to find a link, and I can do this, and I find that these things are actually are linked through various weak links, but now you still don't know whether it's email or whatever else it was. So I can actually go back. Yeah. Well, what I could do is I could right click here. No, let me do it the other way. Let me go back. Instead of weak links, I could have also done just use address, email, and telephone number. But what you'll see is that if I, let's see here, where are the two here?
I'm sorry, Jan, I've lost you. And if
Okay.
I've lost you, maybe a few additional people.
Okay, let me say it this way. So a person could be at an address, right?
Yes.
A company can be, or a person or a company can be at an address for a particular point in time. But you're always at that address from a start time to an end time. So when I just did the weak links, I said, okay, I don't care what the details are, just show me the short connection. So the weak links are the short connection that stand for slightly more complex relationships. What I then as the next step did, I said, okay, let's now look in more detail, at these weak links. Let's look at all the details. That's why you got instantly confused because now you get way more information. Now you find that this foundation was at an address from the January 1st, 2013 at this street in Apeldoorn, and this foundation was from August 2012 to 12. Oh, so it was only one day here. Actually, not even here. This was this one here. This company was at address for this particular time, also at the same address. So what I just showed is that there was a weak link between these two guys, but if I look at the details, it's a way more complex path. All I'm trying to show here is that you can search between links between nodes at various levels of complexity. If you want to keep it simple, but I'll blame it on Art by asking about weak links and strong links, because this went a little bit deeper than I normally go.
But that's powerful. No, I love it. I understand it. But that's a very powerful way of distinguishing links.
Yeah. So it's plus if you have a lot of data, it also makes it more scalable. All right. Okay. So let me go back to here. So, and at some point, these people in the Netherlands also got the Panama Papers, right? All the secret accounts that people had in other countries, and they wanted to link it to their own database. The problem was that the Panama Papers, let's do this here, maybe same name and address. The problem was that the names in the Dutch database were always spelled differently than the names in the Panama Papers, and the addresses were also slightly different. So you couldn't link the Panama Papers directly with the Dutch text. So what we did is we did string comparisons between every name and every address. And if the string similarity was high enough, we created a little extra graph. And so now I can do this beautiful circle query where I say, was there a Dutch entity with the Dutch name that was kind of similar to the Panama name of a Panama entity, and this Panama entity was for a certain amount of time at an address with this string, which is kind of similar to the address here, blah, blah, blah. And I can run this as a query. And this is a query that you usually don't want to write by hand. It's pretty, And again, I get a graph as a result. It doesn't look like a graph, but it is a graph, believe me. And because my query was a circle, my answer is also going to be circles. Any questions about this so far? And then one question is, how do I make these queries? Because you see this query here, but let's just get rid of it and let me go back to my graph screen. By the way,
for clarification, you define templates of relationships, and then you look where these templates take place, and you show us other instances of similar instances for this template.
Basically, it's a database of facts,
and you search it to look for the template of the defined by the relationship, by the specific example. So you extract a template from the example, and then you turn it into a query, and then you have the answers, and then you turn them back into graphs.
Yes.
Got it.
That's actually a very good observation. So I have an existing graph. I'm going to so it is all here. It is all the ways you can look at the graph: table view, outline view, query view, graphical query view. But I'm going back to the graph view. say I had this as a graph on the screen, right? This is a graph. Then I can do, I can take a graph like this, select them, and then I can copy them to my query screen. So now I have, this is a query. I can, for example, take this and I say, turn this into a variable, convert a variable node, and I say, well, this is a person, right? And then I can say, okay, now I want to see how this looks like a query, and I just do say show text to the query, yeah, and I get. And then when I would run this, I don't know if this query will easily. Okay, well, this will only give me one simple result. But then I could show this back into a visual graph. Yeah, so it's graphs in and out all the way, right? You start with graphs, you turn graphs into queries, you turn certain parts of the query in variables, you do the query, and then you visualize, and you get a new graph. Okay, so that is my first demo. Let me go back to, because I don't have that much time. Okay, share screen.
I also have a question when you will have a few minutes.
Yeah.
People use, or at least Google used the term knowledge graph for something totally different than what you're showing us now, because literally this is a knowledge graph and that is a knowledge graph, but these are two different things. So I'm sure you can connect them.
Well, obviously, every time you have a different application, you have a different knowledge graph. But a big part of Google's knowledge graph is based on the Wikipedia, and I can also give you a demo of how we take the Wikipedia, turn it into a graph-based version called the DBpedia, and then do queries against that, right? So when you say different, what do you mean by that?
A knowledge graph is, if I understand what Google defines as a knowledge graph, is a template where it defines for a type of an entity, what are the interesting knowledge items or knowledge components. And then it finds a way, because it's Google, how to select it among endless. It's not only Wikipedia today, if I understand, again, endless sources, and put the bottom lines that are the most important into the structure and turn it to be a very short piece that is very relevant for contact centers, for service centers, because they have the bottom line, and it can be usage of bots, of representatives that are answering phones, etc. So that's something differently. And even though the word graph is part of the term, it's not really something that is visual. Now, you are showing us visual thing, that's okay. But you started and you opened with Google's knowledge graph. So I'm sure you have some connections, or it's only the same naming and everyone has a different explanation, a different set of using the same term for different usages.
Underneath knowledge graphs, every knowledge graph is a graph representation, and that is what everyone has in common. Yeah. So in the Google knowledge graph, there will be the fact Jans Aastman is a CEO, right? Or Jans Aastman is a psychologist. That is two facts that are in the Google knowledge graph, right?
Yes.
And those are the core elements of these knowledge graphs. But I'm now going to talk about for example, about healthcare. Yeah, and now we have patients, and now we have Jans Aastman is a patient, and Jans Aastman has an address, yeah, and he had an inpatient encounter, and the inpatient encounter had a diagnostic, and the diagnostic had a concept, and the concept is headache. Yeah. So strings of
I'm sorry, John and Moria. Could we kind of go to that one afterwards, because there's a lot of chatter on the chat that people want to see the third demo, and then we have 3 other questions, and I just wanted to get to some of the other attendees. Most are saying, can they see the third demo first because of the documents, and also if you'd like to take the 3 questions that have been out there before you go to the demo, would that be okay?
Okay, I could just.
I don't mean to
dive
cut you
into
off,
the demo.
Maury. I'm just trying to give others equal time because we're running, we're gonna be running out of time soon.
Yes, there was no question. That's why I asked, but I got my answer. Everything is good. Please continue.
Okay.
Excellent, okay.
Okay. Well,
Okay,
okay.
so
I'm
you
here.
wanna answer these 3 questions first and then go to the 3rd demo?
I don't see the questions. Where are the questions?
I have them. They're in the chat. I have them. The first one is from Kashif Mershon. It says, are there any privacy issues using the knowledge graph?
Well, I mean, yes. I mean, if you look here at my healthcare example, everything in healthcare is controlled by HIPAA, right? So there are huge privacy complications when we work with patient data. We live under the rules of HIPAA, and in our graph database, so you have a fact. Yeah, you can have a fact. Oh, actually, I have a picture for that here. Let me do this. Where's the fact here? Yeah. For example, you have the fact. Can you guys read this? Or I'll make it bigger. I'll make it bigger. Yeah. Person 1 has diagnostic 1. That's one fact. The next fact is, and this the diagnostic 1 has the pref label bipolar, right? Now you don't want anyone to see that, right? Only certain people are allowed to see that someone is bipolar. So we have a technology where for every fact, we can add metadata, like what is the medical record number for this fact? What is the security level? Yeah, which is 8. And what departments can see this? Yeah. And then are allowed to see this. And then when we do queries, we also add, so this is a person where we say, well, select every person where the person has a diagnostic where the diagnostic is bipolar. Now this person will not be able to see the facts here because the person, when the application does this query, it adds some attributes to the user too. It says, well, this person has only a security level of 2, and the person is from the administrative department. And then because of some security rules that we wrote, we can exclude this person from seeing the result of this query. So we are, that's one of the, I mean, so this, I'm just showing visualization, but of course I give a lot of talk to customers and I have to talk about the thing that makes us special from other graph databases. And one of the things that we are really specialist in is how can I protect data from eyes that are not allowed to see it? Okay, let's keep it at that. Next question.
Okay, this is from Molly Chaudhry. Is knowledge graph similar to social network analysis?
No, a knowledge graph. So well, to begin with, you have, think of it as a stack. You have a graph database. Graph database is just a database where you can have almost like free-flowing facts. Yeah, like person 1 is diagnostic this, diagnostic 1 pref label bipolar. Yeah, that is just the graph. A knowledge graph means it's kind of an application on top of a graph. Yeah, you took a domain. Yeah, you made templates for your data in such a way that you have a systematic way to put the facts in your database. Now you have kind of a knowledge graph, especially if you also add some machine learning, all the other things. But now we have that. Social network analytics is just a set of graph-based technologies to do interesting things with your data. Yeah, so it's social network analytics is a name of, well, it's basically a branch of graph analytics mathematics, yeah, where you come up with interesting algorithms to investigate graphs. That's the shortest way I can answer, and I don't know if it helped at all. Okay, next question.
And then the third one is from Jay. Is it, the third one's from Jay. Is it possible to look at a relationship between 2 entities, say A and B, and use it to predict a probable relationship between 2 other entities, B and C?
Yes. So I just gave a talk, and I can give you that later. There's a recording of the talk where we talk about graph neural networks. That's the hottest new topic in machine learning, where you can look at a graph with sparse data, and then you can start classifying nodes based on the context of the nodes. You can see, You can do link predictions. You can see if a node is missing certain links, and you can predict what kind of links it should have. Yeah, it's like you want to, you know, the old saying, yeah, tell me who your friends are and I tell you who you are, right? Well, that's what graph neural networks is. It looks at the context around nodes, and it then tries to make predictions about what it think is missing or how you should classify a particular node. Yeah, so it's a new research topic, and I just gave a talk about it. So I'm more happy than to give you a link to the talk so you can look at it. All right, so you want to go to the document graph quickly? Yeah.
Yes.
Okay, then so let me quickly. So this is the yeah. So this started about 4 or 5 years ago when we were approached by a group of people. So Noam Chomsky's in his 90s, won't be that long amongst us anymore. And you know him, he's a fierce intellectual with enemies both left and right, but also lots of fans. And there's a group of people that want to make sure that all the publications, about 1,000, are stored for the future, yeah, so that researchers can look at it. So we want to make it easy for journalists, students, researchers, strategists, and politicians to find what he was thinking about certain things. And so what we started out with is to build a taxonomy. Now, I'm sure that most of the people in the audience knows what the taxonomy is. There's various tools that you can build taxonomies with, but we had a bunch of people, mostly Chomsky fans, diehard hippies, build a taxonomy for all the important concepts in Noam Chomsky's work. For example, you have the concept of power with the hard power as a subtopic, with say a war as a form of hard power, with proxy wars, and then Cold War proxy wars, and then all the way to say Vietnam War or whatever war you might have. Yeah, so that is the list, the tree of important words in the domain, and then we use that to extract concepts out of the work of Noam Chomsky. And so we do NLP entity extraction to find it, and I'll show that in a minute. We enrich the data with public knowledge, so we go to other databases like DBpedia or GeoNames to find place names, census database to look at the income in a particular area, and we do all kinds of statistics and machine learning on the data, and we even look at causality graph. Yeah, what does Noam Chomsky says that A causes B? And anyway, given the time, let me just dump into it. So I've stopped sharing my PowerPoint, and I'm going to share one of my graphs that I have here. Okay, so here, let's open, let's go here, let's go to demos. Where is my Crunchbase? Not here, oh yeah, Chomsky 47. Let's see if I can do this. Yeah. Yeah, so this is a very early version, but this is my demo version. So we annotated a bunch of books that were text only, and we turned it in, use a tool called Apache Tika that some of you might have heard of, and turn it into XML. Then we took the XML of the book and we turned the book into a structure containing of, well, chapters and paragraphs. So let's begin. Yeah, so here are the objects in the database. We have interviews with questions and answers. We have books. Books have chapters. Chapters have paragraphs. Paragraphs have concepts like persons and all of that. So, but let's keep it simple. So let's get a book. Here's some books in there, just random books. So let's take the book Media Control. Yeah, it's about how easy people do self-censure in the United States or anywhere. So this is a book Media Control, and it has a bunch of chapters. So I can look at, well, some chapters. So there's 16 chapters, but I'm choosing just a few of them. And then I could look at public relations, and then this chapter has paragraphs. So there's 7 paragraphs. It's a short chapter. I could get some chapters, right? So now I have a book with a chapter with some paragraphs, and of course a paragraph have text. Yeah, so I can look at the content. So here is one. It's a very long paragraph. So this is about this is going back to the business community. Last legal victory for labor really was in 1935. Blah 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 blah. Yeah. Now people usually don't want to look at these long context. So one thing we already do is we look at the summaries. So we do abstractive summaries that are meant to be easy read, and extractive summaries where you see all the important sentences in a particular one. Yeah, so if I could look at this, and here you see, so this is an abstractive sentence. We made it with a Python package called Gensim. And here we have an extractive that is done with a natural language package called SpaCy. There must be people in the audience that work with NLP, so you know these tools, Gensim and SpaCy, right? So now we have a chapter with the content and some summaries, but more interesting is that we want to look at all the concepts in there. Yeah, for example, what are the important words that were in this particular paragraph? Well, for example, there was South Africa and political parties. There was something about healthcare and democracy. Yeah. So now we are here. And well, so these are concepts. So I could look at democracy, right? And this is a term we extracted. The term actually has a bunch of alt labels, yeah, in various languages. Okay, this is not a good example. Let's do political parties, yeah, that have a broader, which is like a government. I'm assuming some people know taxonomy. So what you see is that I started political parties, but I can use it to now go down into the taxonomy. But again, let's not divert. So we have these, and then so we went from book to chapter to paragraph to the important terms that we found in that particular chapter. Now we can say, so we can do a little bit of analytics and say, so if Chomsky talks about South Africa, what are the other terms that he actually talks about? Yeah. So we do co-occurrence and odds ratio analytics, and I can look at, well, give me 1 minute to show you that. Yeah. So there are relationships with some other words. And what are those other words? Just for fun, let me do this. Say from to, and here. Yeah, and what you see is, yeah, if Noam Chomsky talks about South Africa, then it's incredibly likely that he also talks about Nelson Mandela. Odds ratio is a concept that is kind of a normalization of co-occurrence. You know what co-occurrence is, yeah? So do two words appear together in the text, or do two diseases happen together, or do two incidents or repairs in the plane happen together? You can look at these co-occurrences, but co-occurrences need to be normalized for the A and the B term, how often they happen in the population. And so, but believe me, 157 means that always when he talks about South Africa, he also will talk about Nelson Mandela. Yeah. And we can go out to Wikipedia. So if we wanted to, we can always look at the pictures for whatever we see there. Now, Nelson Mandela will obviously happen in many other publications. In the book The Global Discontents Answer. This is an interview, Hegemony of Survival, Who Rules the World. Yeah. So now I'm looking at other articles, and then for each article, and then we do another machine learning thing, and where we say, well, what are the other paragraphs that look very much like this particular paragraph, right? And I can, for example, look at what we call Gensim similarity. This uses word2vec or word embeddings. We have our own ways to look at similarity, recognizing the unpeople, or I could look at the similar paragraph fields that in this particular thing here. Yeah. Or I can even say, well, I have this paragraph here that talks about Nelson Mandela. How would it relate to this? Can I find the shortest path from this paragraph here to this paragraph in this particular book? Yeah, and I will select my predicates again, similar article, similar paragraph, and I can find the shortest path here. And let me do this slightly different. Yeah. So this is a very, very quick demo, but there's so many more things to show. But does it make sense what I did? I took a bunch of books, I turned them into each book into a tree, the tree of a chapter, sometimes sections, then paragraphs. Then for the paragraphs, I analyze the words in the paragraphs. For the words, I look at whether they co-occur with others. I look at similarity of paragraphs, and I can take that then to do more and more and more analytics to go deeper and deeper into the structure and of documents. All right, so I think I'm out of time by now. So, and I've completely overwhelmed you. My apologies for that, but I hope it made some sense.
No, made good sense to me, but I do have a couple of questions.
Yeah.
One from Katab Salman. Is the case when you do more queries, you can get more accurate results when another instance of a search or query is made? In other words, is it a learning system? So, you know, as you do your queries, does the system learn?
Well, I didn't do my healthcare demo, but for example, we have patient data. So I have data of 2 million patients. I can look at the series of symptoms and procedures and medications they have over life. I can start to learn the regularities. And when it happens, when I learn a regularity, I take that regularity and make that a feature of the patient. And now I can use that feature for the follow-up query. So I can start building layers of question built upon learning, if that makes sense. Right? So yes, the answer is a really full yes. We do almost everything I do is learning based.
Okay. And so our next one is from Eileen Strongengary. Where does copyright enter into this?
Copyright. Well, with this, well, this demo here, there's no copyright, because when we did the Chomsky project, we worked together with the Internet Archive in San Francisco. So they literally have all the works of Noam Chomsky available as text, sometimes just as book. They OCR'd it. So in this particular case, there's, as far as I know, well, actually that's not true. So we have, the Internet Archive gave us it all, but we also include articles about Noam Chomsky, and they might be owned by other publishers. But we kind of ignored it for now.
Okay.
More
Vets asked, do plagiarism checkers use similar knowledge graphs?
plagiarism.
Yeah, do plagiarism checkers use similar knowledge graphs?
Oh, no, they use, no, well, a little bit. I mean, actually, I work in Oakland, and one of the biggest plagiarism detection companies in here in Oakland. So I had 2 people that worked for them and now work for me. They use a lot of Elasticsearch technology for that. Yeah, no, I don't think they use a knowledge graph. They should.
Okay, thank you. And we still, I mean, we go to 15 more minutes if there's any other questions or discussions. So I want to open it up to anybody that's still on the line, the participants. If you have any open questions, you can please just unmute yourself and ask the question.
Ven is asking if we can have the third demo, another demo now, because we have yet time.
The 15 minutes? Great. John, so you willing to give us the third demo?
Of course, I'm here at your service, right? I mean,
excellent.
whatever you want. So actually, yeah, okay. Well, then I'll do 2 minutes of PowerPoint, and just to give you a little bit of background, and then I'll dive in the demo. So let me go to the stop share screen. Where's my PowerPoint here? Let's see here. So let me take a sip of tea. So for the last 5 years, we've been working with a hospital in the Bronx called Montefiore. It's heavily sponsored by Intel because this was an initiative that actually started from within the hospital, driven by a doctor that is also a PhD in semantic technology. And so we've been working together, and the dream of the hospital was, so normally what happens is you have you want to build a new application, and basically you get a new database together, and you kind of proliferate the number of silos in your hospital, and it becomes very hard to do machine learning or anything new applications on top of thousands of silos. So the dream that we had there is, can we make one graph, knowledge graph, that can serve any application you can think of? That was the big dream that we started 5 years ago, and we created that. And we used the technology we call the entity event model. I'll talk about it in a minute. But anyway, so we've been working on this a long time. In 2017, we started working on a model to predict respiratory failure, so that we could, better than doctor and nurses, say, oh, this person going to get into respiratory failure, you better intubate the patient. But then we use the same data model to do sepsis detection, or make outpatient appointments, or help with heart failure, or whatever else. So it's been proven a very sturdy data model. We didn't have to create any new kind of shape of data. We could use the same data shape for all these different applications. Very powerful. And it's right now even used for COVID, and for people that are in healthcare. It's even to the point where it's integrated into this big hospital operational system called Epic. Anyway, I'm almost, okay, so before I dive in the demo, so think of it this way. We have chosen in the hospital to be the core object to be the patient. So that we call that our entity. And then everything that can happen to a patient that is anywhere in any database or in any data stream, and we represent it as an event, where an event is a very simple object, with a type like diagnosis or procedure or medication, a time, and a few key value pairs to describe the event. But everything, so instead of going through these thousands of databases with all these columns and complexities, we are able to take that complexity and always turn anything that happens to a patient in this very simple object, which is the object. And then one of the things, this goes way too deep for today, but we can logically and physically group these entities and all the attached events together. And I'm not going to even, well, okay. We have a fact database that is triples, but there's always a fourth element. And we make sure that the fourth element of every triple or quad is the patient identifier. And because we index on the fourth element, I literally can say, give me everything about this patient, and I get everything, which is completely impossible in a regular hospital. Where you say, give me everything about Jans Aasman, because I might be in 1,000 databases. So, so this is the data, and you guys now know graph. So this is the core data shape. You have the core entity, which is a person that has an event, which is called outpatient encounter. And the encounter happened at this time, and this event has a sub-event of type patient diagnosis with the value allergy to peanuts. Now this is an ICD-10 or ICD-9 code. This is the billing code that hospitals use to send to the insurance companies. But this ICD-9 code is then linked to a mapping object that then links to 180 life science taxonomies that we all integrated into one. Yeah, so here you see the taxonomy tree for allergy to peanuts, because allergy to peanuts is a higher, more abstract level allergy to legumes, which is a food allergy, which is related to allergy to substance, which is allergic disposition, etc. So in this database, if I say, give me all the people that have allergy to peanuts, it will start in SNOMED, one of the taxonomies. It will search back to all the ICD-9 codes related to this, and then find all the patients. Yeah. If I say, give me all the people with food allergy, it will actually search back and find 400 ICD-9 codes for food allergies, and you get way more people. And if you say, give me every person with the allergic condition, you get 2/3 of all the people in the hospital, right? So, I mean, that's a little joke. But so this is the same picture, kind of. So we always make this 3 partition between, there's the core entity, which is the patient. Then there are the events that we got from the relational databases or data streams. Yeah, there's encounters with diagnostics with, say, asthma, or there's demographic information. And then we have the third part, which are all the taxonomies that we have. Yeah, this is, well, anyway, what I just try to explain. Yeah, the hierarchy of words that you're using. And the benefits of that, and I'll show you in a minute how I write a query, is, for example, that if I want to say, give me all the people that had, say, gallbladder calculus, yeah, after the year 2010, I can just draw this simple query on my screen, push a button, I get a result. The SQL people probably spent 2 days, 3 days writing this query, yeah, and debugging it, yeah, because the way we created this entity event model makes the data shape way more easy. And I'm going to keep it at it, otherwise I can't do the demo. There's so much more to tell about this, but okay, let me go to the demo, stop share. And then I say share screen, and then I go to, you see my screen again?
Yes.
Okay, so I'm just going to do an interesting demo of what we did. So in 2015, a friend of mine gave his 4-year-old son his first spoon of peanut butter. And half an hour later, they were in the hospital, and the ER doctor gave him an injection with epinephrine, right? And barely saved his life. And then the doctor looked at the kid's medical history and said, oh, I could have predicted this. This kid has dermatitis and asthma. That always goes together with peanut allergy. So my friend who worked for a pharmaceutical company went home and looked it up on the internet, and he couldn't find it anywhere. This is the beginning of 2015. So he knew what I was doing, and he said, Jans, can you look in the data to see if that's true? And so what I did is I took all the data for patients, and I went through every patient to 2 million, and I computed the co-occurrence. How often does a blind left eye happen with a broken right leg? Yeah, or how often does someone have allergy to peanuts with dermatitis? Yeah, so you get this big table of 10,000 by 10,000 of how often 2 symptoms happen together. And then because co-occurrence doesn't mean anything, because everyone has hypertension and diabetes, so that's a huge number, but it's not a surprising number if you know how often both happen. So you need to do a correction, the normalization, we call that odds ratio, and then you get kind of the surprise factor. And I computed all that, put it back in the graph, and now I can do a query where I say, well, if I have allergy to peanuts, what are the top 5 other things related to that? Yeah, and I can run this as a query. And I see that if I have peanut allergy, then dermatitis due to food taken internally is 210 times higher than you could expect. Yeah, or extrinsic asthma is 60 times higher, etc., etc. So I can turn that into a visual graph. Let me do this here. Yeah. And so now you see, and so my friend saw, oh, wow, the doctor was right. And by the way, at the end of 2015, there was a an article in Nature where doctors suggested that if you find that a kid has dermatitis and asthma, you better check them for peanut allergy. But anyway, we were first because we already had found it in our data and I had given talks about it. So then the thing was, my friend said, okay, but are there other statistical relationships between these things here? And I said, well, let's have a look at it. So I select this and I choose from and to, the statistical relationships. And I let the system do the shortest path between every pair here. And then you look at this, you see that the things that link them together are still very much related to this layer here. Yeah, so allergy to other foods, of course. Yeah, or viral pneumonia is also lung related, or common cold is lung related, and another allergy or eczema, right? So what I can now for every symptom in my database tell you what is the most likely next thing you're going to get, right? So, and when I show this to the doctors for the first time, they said, I kind of knew that. I said, yeah. I said, let me then try you. And I said, so what happens if someone in the Bronx doesn't have a home? Yeah? So lack of housing is actually a billing term used for insurance companies because that allows you, for example, if someone needs a shot of penicillin of something, to give it as a shot instead of pills. But anyway, I said, okay, so then if someone doesn't have a home in the Bronx, what is most related to that? And of course, they come up with all kinds of reasons. But then when I do the query, then I find that most related to lack of housing is actually cocaine abuse and alcoholism, right? But more cocaine than alcohol. Does it make sense what I'm showing you here? So I can, for any symptom, look at the statistical knowledge. Yeah. So the goal of my talk today was to talk about knowledge and visualizing knowledge. Well, this is, I visualize for you right now the statistical knowledge about relationships between symptoms. But if I go back to my allergy peanut example, with this tool you can always back, I can also look at the taxonomic knowledge and the medical knowledge. So I can say, let's look at the exact match here. So this dermatitis is linked to ingestion dermatitis due to food, which is a child of chemical-induced dermatological disorder, drug eruptions, and this, right? And then I can even say, so how is this dermatitis, say, linked to, say, asthma, right? In that space of taxonomies, and I would look at child and exact match. And with any luck, it will find a relationship for that. And there's probably too many paths that it will find. So it's at some point it's going to come back and says, oh, I found 200 ways to link them together. Oh, not only, anyway, this one is good. Now, what I hope you see is that, so we have dermatitis due to food taken internally and extrinsic asthma. And if you look at the medical knowledge, not statistical, but regular medical knowledge, and actually you find that hypersensitivity is the thing that links them together. Yeah. So allergy to peanuts, dermatitis, and asthma are all results of hypersensitivity of a particular system. Anyway, that's my demo. Now I'm going to take more queries because again, I don't have this. There's so much to talk about, so much to show. Let's just keep it at this. Yeah, I know I completely overwhelm you guys and I go way too fast, but I hope it at least is a little bit of entertaining.
No, it's been very entertaining, I believe. It's thought provoking. I like this kind of stuff, so I don't know. But I do have a quick question from Nick. How long on average does a project with your solution take to build a new application?
Well, what we specialize in is like 6 to 12-month POCs. Yeah, where because we really focus on these entity event models, and we've done that in various domains. And so usually I can do a POC for a customer in just to get some low-hanging fruit, right? Where I can take some data from your silos, turn it into this entity event model, and do some interesting statistics on your results, and kind of enough that the person that wants to do this gets something that is sexy enough that he can show to his colleagues and convince them that they want to go on. There's no way you can ever sell anyone on building a big knowledge graph that's going to take 5 years. Like for the hospital, we work for 5 years now, right? But recently, I've done for other hospitals or health systems, yeah, very quick POCs, yeah, so that they have something with their own data that is interesting enough that they can convince their colleagues. Yeah, because it's all about convincing your colleagues that this is a good approach, but you never can boil the ocean from day one. So yeah, 6 to 12 weeks is to get something interesting.
So sorry, Jens, you say how many long? 6 weeks?
6 weeks to 12 weeks,
Okay.
yes.
Okay, thank you.
Okay. And then Vincent wants to know how often do you need to update your graph database on the real-time data updated in all of the database you're using as reference to populate your graph database? I know that's a lot, but it's basically how often do you have to update it?
Well, I mean, we deal with production databases. So in the hospital, data flows in continuously, right? And in and we work for a call center. So every time when the agent hangs up on the customer, there's a recording in a system called RingCentral. It goes to an NLP process. The NLP, well, it goes to a recognizer, a speech recognizer. It gives you back a transcript. The transcript, we apply our taxonomies with speech with the NLP, and we get all kinds of insights. Yeah, what were the sales terms, what were the products, what are the competitor products, what were the objections, what were the questions asked, and this goes straight into the database. So all of these things are highly interactive and dynamic.
Okay, and then I'm gonna do the last question that I think you can answer quickly, which is, are there standard domain specific knowledge graphs available to speed up the process? So are there any type of specific templates or standards?
Well, we're promoting our entity event model, right? So I can easily explain it to people. Maybe the question was more about taxonomies. Yeah, the sets of words are important to an industry, and we also see an uptick there. Banks are getting better at it. Life sciences already have it. We have it for call centers. There's some engineering taxonomies out there that you can use as a basis. There's a company called Wand that gives you starter taxonomies. Can be really useful.
Okay.
But you know, I mean, a knowledge graph is a reflection of the kind of business you have. So it's yeah, it's always, you always have to adapt, of course.
Well, I can tell you now that the incoming comments and stuff, everyone was very elated with your presentation. It was very interesting, and you got quite a bit of good kudos. But I want to read this one to you too. Thank you for explaining what no doctor has been able to explain to me in 45 years with respect to the asthma peanut relationship. Probably includes shellfish in there too. So, you know, it was a very interesting presentation and demo, and we again appreciate your accepting our invitation to present. And I think you did a wonderful job. Everyone's quite taken by the presentation.
Okay.
Moria or Art or Vincent, do you have anything that you'd like to contribute?
I just want to end our meeting saying that thank you very much. And next week we will start our new set of sessions, learning about the KM aspects in any AI project. So please wait, and we will surprise you all. It's going to be good. Be there.
Okay.
Okay, well, it's my pleasure.
So, John, could you please to make certain that we get a copy of your presentation to share?
Yeah, I will send it.
Okay. Thank you.
All right.
Thanks, everybody. See you next week.
Thanks so much.
Okay, bye-bye.
Jans,
Thank you very much.
Jans,
Thank you.
alsjeblieft.
Oh, thank you.
Did you say alsjeblieft? All right, okay.
Thank
you.
you. Bye.
Thanks, Jens.
All right, bye-bye.